Okay, the inverse rules for logarithm and exponential functions. A raised to the log base A of x equals x. Remember, this is what power do I raise A to get x? So when I raise A to that power, I get x. And log base A of A to the x equals x. What power did I raise A to get A to the x? X. 7 raised to the log 7 of 10 power. Well, this is the power that when I raise it to 7, it equals 10. So this equals 10. Log base r of r to the k plus 1. Well, what power did I raise r to get r to the k plus 1? I raised it to k plus 1. Log base 5 of 5 cubed. What power did I raise 5 to get 5 cubed? 3. 8 raised to the exponent that gives me 9, then would give me 9. Since the logarithmic statement can be written as an exponential statement, it is not surprising the properties of logs are based on the properties of exponents. The properties of logarithms allow us to change the form of logarithmic statement so products can be converted to sums, quotients can be converted to differences, and powers can be converted to products. Product rule for logarithms. If all these numbers are positive, and a is not equal 1, for any real numbers r. This is the product property. The logarithm of the product of two numbers is equal to sum of the logarithms of the two numbers. What I need you to remember is that x to the x cubed times x to the 4th equals x to the 7th. So that's exactly what we're saying here. The logarithm of x times y equals the logarithm of x plus the logarithm of y when we're using the same basis. These were all base A. Quotient rule for logarithms. I'll remind you that if I have m to the 4th over m squared, it equals m to the 4 minus 2, or m squared. So the quotient property says the logarithm of the quotient of two numbers is equal to the difference between the logarithms of the numbers. So the logarithm base A of x divided by y equals the logarithm base A of x minus the logarithm base A of y. It's again saying when we're dividing, we subtract the exponents, because remember, the logarithms are exponents. And we've already talked several times about x to the cube to the 4th would be x to the 12th. Same thing with a power property. So the log of a to the base A of x to the r equals the r times the log base A of x. So we're taking this power times this power. This exponent is a power. And two additional rules to remember that we know. Since 0 to the a equals 1 and a to the first equals 1, then log base A of 1 is 0. That's the exponent we use to get 1. And log base A of A is 1. We're going to rewrite these expressions, and we'll assume that all variables are positive real numbers. We don't have any variables in this one. But splitting this up, since this is a product, we could say this is the log base 7 of 8 plus the log base 7 of 6. Since this is a product, we change it to adding the two separate logarithms. This is a division, and when you're dividing with exponents, remember you subtract them. So this equals log base 6 of 12 minus log base 6 of 5. That this means the cube root of 9. So this would be log base 2 of 9 to the 1/3. And then we can move that exponent in front, so it'd be 1/3 times the log base 2 of 9. A complicated one, but don't let these complicated ones scare you. When the numerator, we're adding, and an exponent here. So this would lead to log base b of r plus log base b of s squared plus log base b of t. Those are all in the numerator. The ones in the denominator become subtract, so minus log base b of u cubed minus log base b of v to the 5th. Notice I subtract both of those. Now we're going to bring these exponents out. So this leads to log base b of r plus 2 times log base b of s plus log base b of t minus 3 times log base b of u minus 5 times log base b of v. The 1/5. So this leads to log base 2 of r cubed to the 1/5, which leads to 1/5 times log base 2 of r cubed, but we can still bring out the 3, so that makes it 3/5 times log base 2 of r. Here again we want to rewrite this as the long one. Okay, this mth root means we could make it 1 over m times everything. Log base a of r cubed plus log base a of s squared minus log base a of t to the 4th. Now we can bring all of these exponents down, so we'll still have 1 over m for that mth root of 3 times log base a to the r plus 2 times log base a of s minus 4 times log base a of t. Now we can take care of this 1/m. So we'll have 3 over m log base a of r plus 2 over m log base a of s minus 4 over m log base a of t.